So today we're going to start section 5.2, which is sum and difference formula. Sum is adding, difference is subtracting, and we're going to use those when we want to look at sine, cosine, and tangent. So our success criteria, we want to be able to find the sum or the difference of two angles, and when we find that sum or difference of those two angles, it's going to equal one angle. We want to be able to substitute the exact values for either sine, cosine, or tangent. So looking at our unit circle and those radians, being able to put those exact values in there. And then also making sure that we're using the correct formula. If we jump to our reference sheet, on our reference sheet we have a section right under that Pythagorean identity. So that second section on there has to do with sum and difference formulas. There are sum and difference formulas for sine, cosine, and tangent. On here I just have the cosine and the sine, where today we're only going to focus on these two cosines. If mathematically sum means adding, so cosine of alpha plus beta is our sum formula. And then our cosine of alpha minus beta is our distance formula that we're going to focus on. So that success criteria had to do with knowing that two angles, either adding or subtracting them, are going to give us one angle. That is what these alphas and these betas are. They're just our angles. I know back in the day we kind of drew some unit circles out. A lot of times we'd use beta, sometimes we would use alpha. So it's really just like two angles that we are putting together. So what happens though is when we looked at our unit circle, and on our unit circle, if we just think of like the first quadrant, we knew what the exact values were for 30 degrees, for 45 degrees, and for 60 degrees. And there's these angles that are all in between. And we were able to kind of go back and forth between figuring out, going from degrees to radians and radians to degrees. But now we want to be able to figure out what those exact values are on our unit circle. So those sines and those cosine values. And that's where these come into play, right? So we're just going to jump right into it. Make sure you're taking some notes on this while we kind of talk through it. So let's say we want to find the exact value of, I don't know, let's go with cosine of 15 degrees. So let's find the exact value for cosine of 15. So find the exact value of cosine of 15 degrees. And if we look on our unit circle, from what we've gathered so far, we don't know what the exact value is at 15 degrees. So this is where the sums and difference formulas come in. Using like your unit circle, we want to be able to either add or subtract two angles that are going to give us 15 degrees, right? So if I'm looking at my unit circle, and if I think of that cosine of 15 degrees, whoops, I need to find two angles that either I'm going to add or subtract. That's going to get me to 15 degrees. Well, at 15 degrees, I don't know 7.5 and 7.5, or I don't know 5 degrees and 10 degrees. So the sum formula is not going to work. So I'm going to think of a difference. So I'm going to subtract. So if I look at my unit circle, are there any two angles that I can subtract that when I subtract them, I'm going to get 15 degrees, and I know what their values are right now? There's more than one option. But what if I had 60 degrees and 45 degrees? Let's just say those are the two that I decide to pick. If I subtract 60 from 15, am I going to get 15 degrees? Absolutely, I'm going to get 15 degrees. So if I use my difference formula for cosine, because that's what I have here, right? I have a difference. So if I use my difference formula for cosine, I can then figure out what that exact value is for 15 degrees. So first thing I need to do is I need to, which one is alpha and which one is beta, right? Well, I wrote it so that 60 minus 45 is 15. So I'm just going to put these babies in order. So when I look at my alpha is going to be the 60 degrees, and my beta is going to be 45 degrees, right? 60 minus 45, alpha minus beta. So now I want to kind of write that into my this nice little long formula that they have up here, right? Cosine alpha times cosine beta plus sine alpha times sine beta. So I'm just going to write it out, right? So I know that my difference formula is cosine alpha, cosine beta, plus, right, making sure we're using the right one, sine alpha, sine beta. So I said, or I show, so I know that my alpha is 60 and I know that my beta is 45. So now I'm going to make that substitution in for each of my alphas and betas. So now I have cosine alpha, my alpha is 60 degrees, times cosine beta, 45 degrees, plus sine alpha, 60 degrees, times sine beta, which was 45 degrees. So now either I know these or I can look at my unit circle. If I'm talking about cosines, I'm looking at my x values, and if I'm looking at sines, I'm looking at my y values. So what is the cosine value at 60 degrees? Anybody? Yeah, it's 1/2, right? Times, so now I need to find my cosine value at 45. Well, at 45 degrees, we know it's square root of 2 over 2, right? Plus, now I got to jump over to my sines, which are my y values. So what is the cosine of 60? Or that y value at 60 degrees? I think I hear somebody in the back. Square root of 3 over 2. And what is the sine of 45? Square root of 2 over 2. So now I'm just going to do some algebra to simplify this. So what do I get? Square root of 2 over 4 plus the square root of 6 over 4. And I can't combine those, right? Because my square roots, my radicals are different, so I can't combine them. So I can either leave it as two fractions like this, or if I want to, I can write it as one fraction as the square root of 2 plus the square root of 6 all over 4. Right? And of course we know that this cannot reduce, right? Because these are radicals, right? So we can't simplify it any farther. All right, so let's try another one. So let's say they give us, they want us to go through and what is the exact value of cosine of 120 minus 45? We know that it's a difference, and we know that it's cosine. So we know that it is going to be this formula, correct? All right. So we can start off with our alphas and betas. My alpha is going to equal 120 degrees, and my beta is going to be 45 degrees. So my difference formula for cosine, cosine alpha times cosine beta plus sine alpha times sine beta. The more and more we practice these formulas, the more and more we actually might get these babies memorized. All right, so let's see what we got going on. So cosine alpha, my alpha was 120. Cosine of beta, 45. Plus sine of alpha, 120. Sine of beta, 45. Good so far? So now, what is the cosine value at 120 degrees? Negative 1/2. Yeah. What's the cosine at 45? Square root of 2 over 2. Plus the sine of 120 degrees. Anybody remember? Yeah. Square root of 3 over 2. And the cosine, or excuse me, the sine of 45 is the square root of 2 over 2. Using our numeracy skills, we're just going to solve this, or sorry, simplify this. Oops. Hey. There we go. Negative square root of 2 over 4 plus the square root of 6 over 4. So I can either leave it, my fraction like this, or I can simplify this into one fraction is negative square root of 2 plus the square root of 6 all over 4. There we are. Sometimes they like to give us the problems where they're giving us the right side of the formula. So they might want us to find that exact value of, let's say, cosine of 80 degrees times the cosine of 20 degrees plus the sine of 80 degrees, cosine of 20 degrees. So previously, when we were going through these problems, when we got to where we wrote out the entire formula, we knew off of our unit circle that cosine of 120 and that cosine of 40, right? So on this one though, if I look at it, and if I'm thinking of my unit circle, they want me to find the cosine of 80. And on my unit circle, I don't know what the cosine of 80 is. Or they want me to find the cosine of 20. And I really don't know what the cosine of 20 is either, do I? So I'm going to rewrite this like how my left hand of my formula is written. So which one is this? Is this sine or cosine? And is it addition? Is it the sum or is it the difference? So if I hop back up here to my little formula sheet, they gave us something over here on the right, right? Well, I already told you we weren't working on on sines today, so we can skip that one. So it's either the sum formula, if you notice how these are the opposite, or it's going to be the difference formula. And this is telling me that it's the difference formula. So this is the same thing as, of my cosine alpha minus beta, right? So what's my alpha going to be? Yep, 80 minus my beta, 20. So I can simplify this down to the cosine of 80 minus 20 is the cosine of 60. And do I know the cosine of 60? I most certainly do. That is 1/2. And is that the exact value? That's the exact value. So you guys are done. The fourth and final way they might give us this information is they might actually give us the radians. So they might give us the cosine of, oh my, I got stuff all over the place, don't I? Clean this up, Mrs. Fitch. There we go. Let's say they give us the cosine of 3 pi over 4 minus, I'm running out of ink, pi over 6. So they're giving us the distance formula. And our our difference formula is the cosine alpha, cosine beta, plus sine alpha, sine beta. We know this guy is our alpha, and this guy's our beta, right? So let's plop that in there. So what do we have? What am I? Something's going on. I wonder because I'm not flat. Let me flatten this baby out. See if I can do something here. All right, let's try it now. Where was I? So cosine of alpha, 3 pi over 4, times the cosine of beta, pi over 6. I think it's this bracelet. Let me take this in. I have one of those little rubber bracelets, and I think that might be part of my problem. Plus sine of alpha, 3 pi over 4, times sine of beta, pi over 6. So now we got two options. Because they gave us those pi's, we know that it's in radians. So I know we went through and we filled out our unit circle and we filled in the radians. So we can look for the radians and figure out what our cosine of 3 pi over 4 is. Or the other thing is you could turn it into a degree and then find your degrees on the unit circle and go from there as well, right? So I don't know how you guys want to go this. I know that cosine of 3 pi over 4, if I were to change that into degrees, that would be 135 degrees. Or I'm just looking for that 3 pi over 4 on my unit circle. And I know that this is going to be the square root of 2 over 2. Cosine of pi over 6, I'm either looking for pi over 6 or I'm converting that into degrees. And pi over 6 is how many degrees? 30 degrees. So that's going to give me my square root of 3 over 2. Plus sine at 3 pi over 4, or you're still looking for that 135 degrees. We're going to get the square root of 2 over 2. And the sine of pi over 6, or the sine at 30 degrees is 1/2, right? Then we're just going to simplify this. Square root of 6 over 2 plus the square root of 2. Ooh, so I can't even do math today, can I? Square root of 6 over 4 plus the square root of 2 over 4. I can either leave it as two separate fractions, or I can make it one fraction, so the negative square root of 6 plus the square root of 2 all over 4. All right. Have a wonderful day. Talk to you soon. Bye.